This is a subscript. Too many people were putting it as if it were right next to T. It should be lower. How do we write reflections? What letter do we use? R. And then what is the subscript? Y equals what? X. That's your reflection line. And then you put your figure, whether it's a quadrilateral, a triangle, a segment, a point. This says reflect segment PQ over the line Y equals X. So that's an expectation that you do. All right. Then you are going to have a problem like the oblique line worksheet. Oblique line worksheet. That would be A29, where you had to graph the reflection over a slanted line. Do you remember that? You are going to have one where you have to write the equation of the reflection line. And that's like the one that nobody asked questions on, A29.5. And then you're going to have to reflect a figure over a horizontal or vertical line. That was from the book assignment. Horizontal or vertical line. So the last two worksheets, you've got to do one of each. That's also going to be on your test, one of each. Writing, translating words to the reflection notation is going to be probably on both the quiz and the test. Reflecting a figure over a horizontal or vertical line. You will already have reflected a figure over an oblique line, but you also have to do it over a horizontal and vertical line. And then I'm putting on the composition of translation. Does anybody have any questions? So when I send you a reminder on Monday, on Remind 101, to study for your quiz, what notes do you go look at? These notes. And then these notes will hopefully tell you where to go from there if you don't remember. Did you have step-by-step directions for both 3 and 4? Now, just because I put them in this order does not mean they're in that order on the quiz. Any questions? 5. Okay, I'm telling you what's on it. It's up to you to make sure you know it. All right, so we are not doing A30. It's an investigation. We're going to skip that. We're going to go on to just rotations. So, Becky, I'm going to ask you to see hardly anybody go on Khan Academy. If no one's going to be doing this, then I'm going to make it mandatory. But the beauty of these are at least, the Khan Academy is Common Core, and this part of the standard is Common Core. This Florida put in front of it to make it look like a Florida standard. But you can look these up on Khan Academy, and you can practice problems. So now we're going to talk about a rotation. Rotation of x degrees about a point R, called the center of rotation, is an isometry with 2. Now, what does it mean to be isometry? Isometry is a special word. This is CC9. CC9. Isometry with 2 properties. The image of R is, if you want the image of its center, it's going to be itself. then for all points like V, RV prime is going to equal RV. And angle VRV prime is equal to the x degrees that we had up here that we talked about. Rotation, in, I guess, simple terms, is a turn. Translation was a slide, reflection was a flip, rotation was a turn. However, they're not going to use the turns, the flips, the slides as vocabulary on your EOC. So you are going to need a protractor and you are going to need a compass. Because I'm going to show you how we can reflect or do our rotate a figure, and then we're going to practice, or we're going to focus more on the coordinate plane. And I think, and why don't you go ahead and get your little foldables out, because I'm sure there's a foldable page. Oh, here we go. We're ready for the foldable. So this should be on the reflection part of your foldable. It is an isometry. Isometry means rigid. Rigid means congruent figures. Oh, sorry. This should be, I didn't bother to change this. This should be on the rotation column. Thank you. Okay, isometry means it's a rigid transformation, which means it keeps you with congruent figures. And because it's an isometry, and if you look back at the other two, it preserves length. It preserves angle measure. Rotations preserve orientation. Which one switched orientation? Reflection or translation? Reflection changed it. It maps each point on the pre-image to only one point on the image. So because it's an isometry, it follows the length, equal lengths follow, and equal angle measures follow. Now, isometry can either maintain orientation or change it. Unless otherwise stated, if it's not stated, rotations are in a counterclockwise direction. But I want to go a little bit further. If x degrees is positive, you rotate counterclockwise. This is a sneak peek to trig. If x degrees is negative, then you will rotate clockwise. This is really, really important. Is that a little bit better, Carlin? Okay, little r, capital R are significant. Reflection starts with R, rotation starts with R. So they have chosen to let rotation be capital R. No, they've chosen reflections to be capital R and rotations to be little r. So what are they saying here? This means rotate point W around point P x degrees. That's an x comma P. So that means rotate point W or figure or triangle ABC around point P x degrees. So basically the degrees are first, and then you've got your center of rotation. That's what that is. And why did they use parentheses here and they did those funky little gizmos for translation? I don't know. So you should have protractors available right now, and you should have compasses available. Because we are going to, and I'm going to try to do this on the notes so that you can go back and look at it. Rotate a figure that's not on the coordinate plane. What is what? Degree. Oh. It's rotate point W around point P x degrees. I'll make this bigger so you can see it. When you have R, x, comma, P, that's a comma. X is your degree, and P is the center of rotation. I was just trying to decipher this. You with me? But it was so tiny up there, it doesn't look very good. So I'll move it. So we're going to rotate a point about some other points. So when I do this one rotation, if you have a triangle, you have to do it 3 times. So to draw a rotation of a point, so this is saying rotate point C how many degrees? 70, about what point? R. So measure an angle. So first of all, we have to draw RC. Now, depending on how big your protractor is, you might have to draw really long. You might have to draw ray RC. So now I need a protractor. I got mine. No, I don't. There, I got mine. You don't have one? You don't have one? You don't have one? They're available. So we're going to take our protractors, and I need to rotate it. Yeah, you need a compass too. There we go. All right, so you see how I put my protractor, hopefully, I've got that center there. All right, so I've got that ready to measure. How many degrees do we want to do? 70. So 40, 50, I'm on the inside track because that's 0. 40, 50, 60, 70. So now you make a mark and then you draw a line. You move this out of the way. So measure an angle 70 degrees in a counterclockwise direction. You see, I could have gone in a clockwise direction, but because 70 was positive, we go counterclockwise with R, the vertex, and ray RC one side. Construct an arc on the new ray. All right, so are you with me? You need a protractor. Oh, you got one. 70 degrees. So I'll put my protractor back. So I put it center on R, and I went to, this is 0, 10, 20, 30, 40, 50, 60, 70. Right. Did you draw that ray? So I'm going to make sure that we know that's 70 degrees. Now you need a compass. Right, you got to go this way because it's positive 70, and that is a 70-degree angle. So now what we're going to do is we're going to duplicate the segment. So you're going to put your compass point on R. Then you're going to open your compass until your pencil point falls on what? C. We need our pencil point on C. Do you have it there? Okay, so if you have it, now what we're going to do is we're going to come over here. Notice my compass point's still on R, and we're going to draw an arc. And where this arc intersects this ray is my C prime. So I've just rotated C 70 degrees. Remember, our rotations preserve length. That means that this RC must equal RC prime. C is going to be somewhere along here, but it's got to be found such that it's the same distance away from R. Was that hard? Let's do the same, something similar, but let's do it in a negative direction so you understand what that means. So if they ask you to do a rotation, should I expect to see a construction? Okay, and we're using a construction that you already know, and that's how to duplicate a segment. Okay, so now we're going to draw, but this time we're going to make this, we're going to perform our negative 60D. So it says draw a point B and a point D. There's my D. Here's my B. Well, I didn't make a very good B. This is B, and this is D. So which one's the center? B or D? Say again? D. How do you know D is the center and not B? Because the center is in that subscript. All right, I don't need those last two. Oh, I needed that one. You with me? All right, I had a compass. Oh, wow, I did not want to make it big. Hold on. I made it huge. All right, so I'm going to move this down, and we have my compass available. All right, so now if I want to go in a counterclockwise direction, am I going to measure this way? How am I going to measure? I've got to turn this. So now I'm going to measure this way. Maybe I'll make it a little bit bigger so I can see it. All right, so I'm going to put my center of rotation there. I'm going to rotate this till... Now which numbers do I look at on my compass protractor? The inside or the outside? Outside. So this is 10, 20, 30, 40, 50, and it said 60. Notice I'm rotating in a clockwise direction. That's because that's negative. And you're going to draw a nice big ray. Then we're going to move our compass, our protractor out of the way. I'm going to try to go get, now what do we do with our compass? We put the compass point on D and our pencil point where? On B. Not working. Okay. And then what?
To the other side. Make a arc.
So this is going to be what? This is B prime. What if I wanted to do segment BC? Let me move this out of the way. Oh, because you're going to have to do more than just a point. What if I wanted to do segment BC? And let's say, put a C somewhere over here. There's your C. What if I just rotated? Only B. So now, if I want to rotate this segment BC, then I'm going to have to do this construction all over again. In other words, I'm going to have to start at D, pass a ray through C, ignore the fact you've done B. You're going to get your protractor again, and now I'm going to line it up with that ray. And how many degrees do I need to go? 60. So I'm going to do this one in black so you can see the difference between the first and the second one. So there's my 60. And once I move that away, where am I going to put my compass? On. And I'm afraid I put C too far away. I don't know if my compass will open that fat. If it doesn't, what am I going to do? Okay, this is what I'm going to do. I'm going to make an arc, and then I'm going to come down here, and I'm going to make an arc. Okay, then I'm going to get this shorter. I'm going to come to this point. Now, you should be able to open your compass and get C, all right? You should not have to do what I'm doing. I'm improvising. So now I'm going to come down here on this one. So what I did is I just kind of did a segment addition to get it. You should be able to do it with one compass arc. Were you able to do it with one compass arc?
Yeah.
So now this is C prime. So your segment, your rotated segment, I'll make it dotted so we can see it, is right there. So you see that segment BC was rotated over there. So if you have a third point, you have to do this a third time. So the construction we did is the basic construction for moving a single point. So if you have 2 points to move, then you have to do it twice. If you have 3 points to rotate, you have to do it 3 times. If you have 4, you have to do it 4 times. Okay. So I just did a segment. We would have just, so I'm going to go ahead and go to here. Here is a YouTube video of rotating a figure. Or you can look at this one. All right, I need you to get out graph paper now, because I want to kind of try to help you make sense of what's going on. Now we're going to be on the coordinate plane. You're going to like this if you know the rules. So I need you to plot 5, 3 on a coordinate plane. You're also going to need patty paper. So maybe I can make my own patty paper, you think? Let me try to make my own patty paper. So in the meantime, you get your graph drawn while I make patty paper. I think I'm going to make it teal. See my patty paper? So So it says, place a sheet of patty paper over the coordinate plane and trace point P. So I'm going to trace point P and the positive x-axis. So I'm going to trace the positive x-axis to my patty paper. So while you do that, I have to move my coordinate plane so that I can make sure all this stays on my patty paper. Okay, but I really didn't want point P. This is so difficult. All right, so I will go ahead and we'll still go ahead and group this. All right, so are you with me? Let's put our coordinate plane back up. So here we go. So now the deal is to take your patty paper and you want to put your pencil point on the origin, and we want to rotate this until the blue line is on the y-axis. So I'm going to have to adjust mine a little bit. So now mine is on the y-axis. All right, since I lost my first point, I'm going to go back to 5, 3. That was P to start with. We just rotated. You are to place a sheet of patty paper over the coordinate plane, trace point P in the positive x-axis. So you should trace P, you should trace your positive x-axis, put your pencil point on the origin, turn your patty paper till the positive x-axis lands on top of the positive y-axis. All right, so the coordinates here are no longer 5, 3. What are these coordinates? 1, 2, 3, negative 3, comma, 1, 2, 3, 4, 5. So the original points were 5, 3. So my question to you, if this was the ordered pair x, y, what is its 90-degree rotation going to be? Look at these numbers and look at these numbers. What happened to the numbers? They did what? They flipped. And what else happened to the numbers? One of them. Which one turned negative? The x. So a positive 90-degree rotation is going to be negative yx. In other words, it says switch numbers, take opposite of the first. To be honest with you, this is how I made sense of it. If we've got a line here, correct? We've got a line here which is perpendicular. So this slope would be the change in y over the change in x. Okay? Y over x. The perpendicular slope is going to become the opposite of that one, correct? Over the change in y. So this becomes the new y. Actually, the negative is going to be down here. This becomes the new y. And this becomes the new x. This is the new x. So this x, this y becomes the x and it turns opposite. This x becomes the y. That is the understanding as to why. Do you have to be able to go in this direction and do that? Or can you remember this?
I like the negative y-axis.
Yes, I do too. So if I gave you the ordered pair 3, negative 7, what's a 90-degree rotation? And this is always going to be about the origin. What would be a 90-degree rotation be?
7, 3.
It would be 7, 3. Now, this is hard to do if you don't know this. You have to put this to memory. Okay, that'll be another quiz. That'll be on your rotation quiz, which most likely will be Wednesday. All right, so draw another coordinate plane. We have, or use the same thing that you have. Go back. Let me get my patty paper. All right, you have your patty paper. I want you to put it back on top the way it was. All right? So that means you're going to unrotate it, put it back where it was. Now this time you're going to put your pencil point here, and you're going to rotate it until this axis falls on that axis. We want to do a 180-degree rotation. So you're going to rotate it until the x-axis falls on the negative x-axis. So it should be like that. So this new ordered pair right here is going to be now -5, -3. That was a 180-degree rotation. So now look at the coordinates. If these coordinates are x, y, what does a positive 180 degrees do to those coordinates? No flipping them, just turn them what? Opposite. Opposite x. Both go opposite. But there's no switching of them, right? So if I ask you for a reflection of a positive 180 about the origin of, let's say, -8, +1, what would its rotation be? Well, 8's already negative. +8, -1. All right, so I want you to make sure that these negative signs actually mean opposite. Okay, these mean opposite. You need these rules for tonight. All right.
So wait, what was the, you know how 90 degrees -x, what negative y-x, what's on?
With what?
What's up on your
No, we're only going to do the 90, 180, 270. Oh, the 180 is opposite. Opposite. Take opposite of them both, leave them as they are. Okay, so I want you to take your patty paper, put it back where you were, where it was. Unrotate it. Oh. All right. Now what we're going to do is we're going to do 270 degrees. 270 degrees. 270 is 180 plus 90. So if I rotate this 90 degrees, I'm here. And now if I go an additional 180 degrees, I will be all the way over here. So your 270 is done when the positive x-axis is on the negative y. This new ordered pair is +3, -5. So now, if I want to do a 270-degree rotation about the origin of a point x, y, what happened this time? Look at the p and look at the new p.
y negative.
So the x's and the y's flipped again, right? But now it is the y became the x, so now the negative is on the x because that's the new y. So if I gave you the points, let's say I ask you for a rotation of 270 degrees, 0, of 12, -3. What would that be? Flip them, and that y stays the same, but the x does what? This means, so we take the y value, which is -3, and we take the opposite of the x. That would be its 270-degree rotation. So on your homework tonight, you're going to be given lots of ordered pairs, and you're going to be asked to do different rotations. Yes? Your homework is A31. We're skipping A30. If there is a worksheet, I'll make sure it's online. I know that I do have a worksheet. I just don't know if that's tomorrow or not. Now, if you do 360, do you agree you come back to where you were? All right, so that one is just... All right, so I'm going to go ahead and fill this in. Remember, this was opposite y. Keep the x. This was opposite both. This is a summary what we just did. This is going to be y negative x, and 360 means it falls on top of itself. Yes, your homework is A31. Oh, I need your A29.5, yes. And I need my protractors put back if you borrowed one. And you can put the homework on that desk back there.